Hello, everybody. This is Chemical Charlie and my buddy here, Pie Guy Pepin, and we've got a fidget spinner in here. The first thing we're going to do is spin it and time how long it takes for it to stop. Almost 20 seconds. I'm going to remove the vise. Now, one of the things that we learn in physics is that there's conservation of linear momentum and conservation of angular momentum. Well, a spinning thing is angular momentum. And if you actually hold a fidget spinner in your hand and move it, you could feel that there's a resistance to you moving it because it wants to maintain a constant angular momentum, which has a direction perpendicular to the motion. So I'm going to spin it, but then I'm going to start moving it. So you could actually hear noise. And you can see that after less than 10 seconds, it stops. All right. It wants to go at a constant speed and a constant direction. The speed slows down because of air resistance and because of friction in the ball bearings. But the direction changing puts torque on it and causes it to slow down. Okay, well, we've also done it in a horizontal arrangement. So we did 10 trials, and here are the results in seconds, and 10 trials for the other one in seconds. We tried to spin them with the same force, which is not easily done, but we did the best we could. The average for the vertical was 19.6 seconds, whereas for the horizontal it was considerably higher, 34.5. 15 seconds higher. The median was higher for horizontal. The standard deviation is larger, but for the larger value, which is not unexpected, but there was a little more variation for some reason. 95% confidence was 9.7. So 34.5 plus or minus 9.7 is larger than 19.6 plus or minus 2.4. So we can feel confident that it is spinning a significantly longer time in the horizontal position than in the vertical. And after thinking about this for a little while, it did make sense because when it's in the horizontal position, it's kind of sitting evenly on the ball bearings. Whereas when it's in the vertical position, it's sitting on the lower ball bearings more than the upper ball bearings. And so it may not getting as smooth a displacement. Okay, we're going to look at the effect of a magnetic field. I've got a neodymium magnet, which is a very powerful magnet. You got to be careful with these. So first I'm going to spin it without the magnet. You can see it spins quite nicely. Now I'm going to put it on top of the magnet. And the arms are not attracted to the magnet. Even this little thing isn't magnetic. It's this part in here that's probably the steel. All right, so watch the difference now. I'm going to spin it as hard as I can, and it doesn't spin very much at all. It's probably pulling the ball bearings up toward the magnet and causing them to have more friction with the sides of the thing that it's embedded in. Okay, thank you.